Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to be looking at a chemistry question under the topic reaction kinetics or chemical kinetics, that is rates of reactions. So the question reads: the data below was obtained from the reaction between iodine propanone in the presence of an acid catalyst. Here is our reaction where we have propanone reacting with iodine to give us this is actually iodoform test, I suppose, because it's in the presence of a catalyst. All right. Anyways, we have the various experiments. So 5 experiments were carried out, and these 5 experiments that were carried out, we have the respective concentrations of the reactants, then we have the rate of each experiment. So the first question is asking us to determine the order of the reaction with respect to our 3 reactants. We cannot see the acid catalyst in the reaction, but we see its concentration because it's actually a catalyst, so it's kind of a reaction condition. All right, so H plus here is just for the acid. So we need to determine the order of the reaction with respect to these 3 reactants. Then we state the overall order of the reaction, we write down the rate expression for the reaction, and then we calculate the value of the rate constant indicating its units. So while I explain, if you have any question, the comment section is open for you to ask your questions, but I'll try my best to explain in such a way that you will be able to understand to the fullest. I will not do the punching for you. All right, you will do the punching and you tell me your responses in the comment section. Okay, now let's begin. So if I want to determine the rate, if I want to determine the order of the reaction with respect to the reactants, we call that order the partial order. All right, and then the overall order is just gotten by summing the partial orders. So first of all, what I'll do is that I will write down the rate law of this chemical reaction. Now the rate law says that the rate of any chemical reaction in any experiment is equal to the rate constant, we call it K, times the product of the concentration of the reactants raised to their partial orders. So my rate law says the rate of this chemical reaction will be given by the rate constant times the concentration of the first reactant raised to its partial order. I can say the partial order is X, and then times the concentration of the second reactant raised to its own partial order. I can say Y, then times the concentration of the third reactant raised to its own partial order. I can say Z. That is the first thing you have to do. K is the rate constant. When we put this bracket, it represents concentration. Now this X here is the order of the reaction with respect to our propanone. Y here is the order of the reaction with respect to iodine, and Z is the order of the reaction with respect to the acid. So if you want to determine the order of the reaction with respect to these 3 different reactants, follow keenly what you have to do. Now this rate law satisfies all the experiments, which means that rate 1 will be equal to the rate constant times the concentration of the first reactant in rate 1 raised to the power X times the concentration of the second reactant in rate 1 raised to the power Y times the concentration of the third reactant raised to the power Z, and the value of the rates is given for rate 1. All right, so let's just collect the data. So we have rate 1 is equal to our rate constant K times what is the concentration of the first reactant. It is 0.3. We raise it to the power X. What is the concentration of the second reactant? 0.05. We raise it to the power Y. What about the third reactant? 0.05. We raise it to the power Z. But what is the value of rate 1? Rate 1 is given by 5.7 times 10 raised to the power -5. so I can call this equation 1. Now let us go to rate 2. For rate 2, the rate constant is constant for all the experiments. Okay, so for rate 2, my rate for rate 2 is equal to the rate constant. What is the concentration of the first reactant? 0.03 to the power x. What about the second? 0.10 to the power y. What about the third? 0.05 to the power z. But what is the value of that rate? It is the same. So the rate was constant in experiment 1 and in experiment 2. Now let us go to the third experiment. So we have our rate constant K. The concentration of the first reactant is 0.03 raised to the power x. For the second is 0.05 raised to the power y, and for the third is 0.1 raised to the power z. What is the value of the rate of the third experiment? Is 1.2 times 10 raised to the power negative 5. So we can call this equation 3. Now let's go to rate 4. Rate 4 will be equal to, we have K, then we have 0.4 raised to the power x, we have 0.05 raised to the power y, and we have 0.2 raised to the power z. What is the value for rate 4? What is the value of the rate for experiment 4? Here is it. We can call this equation 4. And finally, let's go to rate 5. So for rate 5, we have 0.36 raised to the power x times 0.05 raised to the power y times 0.05 raised to the power z equal to, what is the rate for experiment 4? Here is the rate for experiment 4. So we have, for experiment 5. So that is equation 5. Now follow keenly what we are going to do. So we now have to be very vigilant. Okay, we have 5 equations, and in these 5 equations we need to find just 3 unknowns. Okay, we need to find x, we need to find y, and we need to find z. Though there is a k here, that is 4, that basically we have 4 unknowns to find, because in Roman 4 of the equation we are asked to now calculate the value of k. But for the first part, now how do I calculate the value of x? Alright, because x is the order of the reaction with respect to propanol. Specifically, we call it the partial order of the reaction. So how do I calculate the value of x? What I need to do is that I need to go to any 2 reactions. Okay, I need to go to any 2 experiments where the value of the other reactants are constant. That is, the other reactants have constant rates. Okay, then I use that to find my value. Now check, you see that in experiment 1, iodine and the acid have same concentration. In experiment 5, iodine and the acid have the same concentration. So I am going to use equation 1 and equation 5. Now look at what is going to happen. If I take rate 1 divided by rate 5, what am I going to have? Now what is rate 1? This is rate 1. Alright, so let me just copy and paste. That is rate 1. What is rate 5? This is rate 5. Okay, this is rate 5. Now you clearly see that we are doing that so that these 2 terms, this term here, we cancel off with this term. Alright, and then it will be easy. It will be easy for us to get, oh, we missed the k. It will be easier for us to get the value of x, because k will also cancel. But now in actual sense, what is actually rate 1? This is the value of rate 1. Okay, and what is rate 2? Sorry, what is rate 5? This is the value of rate 5. Okay, so all we need to do now is apply mathematics and solve. So the first thing is that k is going to cancel with k. 0.05 to the y, we cancel with 0.05 to the y. 0.05 to the z, we cancel with 0.05 to the z. So on the left hand side, we'll just be left with 0.3 to the power x divided by 0.36 to the power x equal to, now 10 to the negative 5, we cancel with 10 to the negative 5. So we are going to be left with 5.7 divided by 7.1. Now from here you see that we apply indices since they have the same base, and since they are raised to the same power, we can just divide the bases. So we have 0.3 divided by 0.36, then we raise it to that common base, then we equate it to let me see if I have a calculator beside me. I'll just punch. All right, so you also punch to see if you have the exact value. So we have here 5.7 divided by 7.1. It gives us approximately 0.8. Now if we take 0.3, divided by 0.36, we get 0.83333. Anyways, from this instant, the best thing to do is we just apply logarithm on both sides. All right, so this might actually something like this. Now if we apply logarithm on both sides, your x will just be equal to the logarithm of 0.802 divided by the logarithm. Now when I punch this value, I had 0.833. all right, so if you punch that, let me see what I'm going to have. So the logarithm of 0.802 divided by the logarithm of 0.833, and so on and so forth. So approximately I have 1.2. okay, I have an approximate value of 1.2. anyways, let me try to use a whole value, that is the logarithm of 5.7 divided by 7.1, okay, divided by the logarithm of 0.3 divided by 0.36. yes, we have an approximate value of 1.2. so this approximates to 1.2. but since these partial orders are whole numbers, we are going to round it down to 1. all right, so we are going to say it is identically equal to 1. so it is identically equal to 1, which means that the order of the reaction with respect to this man is first order. all right, so since the value of x is 1, then it is first order. Okay, now let us move on to finding the order of the reaction with respect to iodine. Now what we'll do is that we now go and check where propanol and this other guy are constant. Now you see that let us see 0.33 repeats, and it repeats here. So we are going to use in rate 1, what is the concentration of this man? In experiment 1, the concentration of this man is 0.3. anyways, I don't think it does not repeat there. It repeats here. okay, it repeats here, but this guy does not repeat here. It has a different value, so we have to look at what we are going to do here. Let us see, this man is 0.2. anyways, let us see what we can do. Here we have 0.03, and it is constant here as well. And then okay, anyways, I think let's just try experiment 2 and experiment 3, and then we'll also try other experiments to see what we are going to have. okay, because in this case the values are bizarre. So if I take experiment 2, rate 2 over rate 3, rate 2 over rate 3 is equivalent to, this is rate 2, okay, here we have rate 2, here we have rate 3. Let's just simplify to see what we have at the end of the day. Okay, now if we simplify, the only thing that we cancel is this man. This man is going to cancel, okay, and if that man cancels, we are going to be left with y and z. That is now a problem. That is now a problem. So I think it is preferable for us just to take where, since we have already found the value of x, right, let's just take an instant where this man is repeating, so that is going to cancel. So let's take rate 1 and rate 2, because in rate 1 and rate 2 it repeats, or rate 1 and rate 5, any of them. It's just that if we take rate 1 and rate 5, iodine will also cancel, so we better take rate 1 and rate 2. So if I take rate 1 divided by rate 2, what am I going to have? Now this is rate 1, okay, this is rate 1, that is rate 1, and this is rate 2, that is rate 2. In actual sense, what we are saying is, we need to take this man 5.7 here, and we also take this man. In fact, anyways, it's going to give us 1, so we don't have anything to worry about. Now what happens is that this man here, we cancel with its counterpart in the numerator. K here we cancel with its counterpart in the numerator. Now since we have the value of x already as 1, this man here is going to give us 1, okay, so everything there is going to give us 1. So at the end of the day, what are we going to have? At the end of the day, we have something like, this man is going to give us 1. Anyways, here we have, since x is 1, okay, we are just going to have 0.3 divided by 0.03 times. Now since these two guys here have the same power, we'll just divide and then we raise it to that power. So you are going to take 0.05 divided by 0.10, okay, then we raise it to the power y, then we now equate it to 1. Alright, so from here now, we can now, if I take 0.3, let me punch and see what I have. So if I take 0.3 divided by 0.03, I get 10. So this is going to give me 10, but I'll be dividing both sides by that 10, okay, and when I do that, let me also divide this man, that is 0.05 divided by 0.1. I have 0.5, so I'm going to have here 0.5 raised to the power y equal to 1 divided by 10. I'll now take ln on both sides, okay, and if I take ln on both sides, I will have that x will give me the ln of 1 over 10, that is the ln of 0.1, okay, divided by the ln of 0.5. Then we now approximate our value. So let me try to do it. The ln of 0.1 divided by the ln of 0.5. We have an approximate value of 3.32. So since it's 3.32, we are going to round down to 3. Okay, we are going to round down to 3. So we have 3. So which means that the order with respect to iodine is third order. That's third order. And finally, how do I find the order with respect to the acid? Okay, so we now just have to look for where these two guys are constant. Okay, so let's see. I think we can use equation 2, rate 2 and rate 3. We see that this man is going to cancel off. We already have the value of iodine. So even iodine does not cancel, we don't have any problem because we have the value of iodine already. Or in fact, let us use rate 3 and rate 4 so that iodine should cancel, since we know that the value of this other guy is 1. So let's take rate 3 over rate 4. So for this one we are going to take rate 3 over rate 4. Now rate 3 over rate 4, what is our rate 3? This is rate 3, okay, so that is rate 3 there. And what is rate 4? Here is rate 4. Here's rate 4. In actual sense, rate 3 is given by this, and rate 4 is given by this. Rate 4 is given by this. Okay, so K is going to cancel with K. This man is going to cancel with this other guy. So at the end of the day, what are we going to have? We are going to have something like, okay, now on the left hand side we are just going to replace x with 1 because we had the value already. So we are just going to have here 0.03 divided by 0.4. Now what will be left is 0.1 divided by 0.2, all that raised to the power z. Okay, then on the right hand side we are just going to be left with 1.2, so equal to 1.2 divided by 3.1. Now all we need to do is we have to find the value of z by taking logarithm on both sides. Okay, so with that said, you see that our z will just give us let me punch 1.2 divided by 3.1 and see what I have. 1.2 divided by 3.1 gives me 0.387. So I'm going to have the ln of 0.387 divided by the ln of, now 0.1, we have to before doing that, I think we first of all have to cross multiply, right? We have to first of all cross multiply. So I'll take the 0.087. So I'm going to take 1.2 divided by 3.1, then times 0.4, then divided by 0.03. I have 5.161. 5.161. Now if we take 0.1 divided by 0.2, we get 0.5. And there's going to be a problem. There's going to be a problem here because z is going to be negative, and we cannot have negative orders. Let me try to punch again. Let me check again these experiments. We took, let me say we took which rate? We took 3 and 4. We took 3 and 4. There is 0.03 and there is 0.4. Let me check the original equation to be sure that that is what is there. Yeah, 0.03, 0.4. Yes, that is it. Now the next one is 0.05, 0.1, 0.2. Okay, it is times 10 to the negative 4. But anyways, it's still the same thing. This one is times 10 to the negative 4. This one is times 10 to the negative 4. If that's the case, have we used rate 3 and rate 4 before? Okay, we have not used it before, so the values are not affected, the rates are not affected. But even if you put negative 4 here, is it going to cancel? So rate 3 on rate 4, rate 3 has 0.03, rate 4 has 0.4. Because I think there should be a problem with this value here. Anyways, let me punch again. 1.2 divided by 3.1, it gives us this value. We have to multiply it with 0.4, then we divide it with 0.03. Yes, I think I have 5 point. So everything on the right hand side will be giving me 5.1. Now under rate 3, I have 0.1 there and 0.2. So I think there is a problem. There is a problem here, because if we take the ln of 5.161, the ln of 5.161, and then we divide by the ln of 0.5, we get a negative value. It gives us negative 2 point, and z cannot be negative. So surely there should be a mistake with the values, okay? Or maybe I don't know if I've done a punching, if I've punched wrongly, or I collected the data wrongly. But there should be a punching, there should be a value with, there should be a problem with one of these values here. Yes, there should be a problem with one of these values here. The values are bizarre. This 0.4 and 0.36 have bizarre meanings. But anyways, let me just explain to you guys in the next step what is the overall order. Our overall order is just gotten by taking x plus y plus z. Alright, now the rate expression is just rewriting what we have here, but replacing x, y and z with the answers we have gotten, and then calculate the value of the rate constant. So to calculate the rate constant, you can just come in this equation, okay, and then you put your values, you put your x, your y and your z, and then you use any of the equations, which means that you could use rate 1 equal to k times the first constant. In fact, you could just come here and you find the value of k by dividing, by taking rate 1 in experiment 1 divided by everything here. After replacing x, y and z, you have the value of k, and then I believe you can work out the units. Yes, you can work out the units because you have the units of the rate. Now the unit of these concentrations, you raise it to the power 3. Then when you divide, you're going to have mole per dm cube per second divided by mole cube per dm cube. Then you simplify to have the result. But anyways, like I said, you try to tell me in the comment section if I made a mistake while punching, because for now I don't spot any mistake. Alright, so basically that was it for the equation. Thank you guys for watching. If you have a problem, the comment section is open for you to ask your questions. If you have understood, make sure you also indicate in the comment section. See you guys in the next video.